Hi, let's talk about vertical asymptotes. A vertical asymptote is a vertical line that a graph approaches but never actually touches. And I've got two sort of basic examples right here. The first one, f of x is 1 over x minus 3. On this one, we've got a vertical asymptote at x equals 3. Notice it occurs at the value of x, or at a value of x, that makes the denominator 0. And if you look at the other example, we've got a vertical asymptote here at negative 2, and negative 2 is the value that makes this denominator 0. Now, one thing you might notice is over here, if we approach from one side, we drop to negative infinity, and approaching from the other side, we go to positive infinity. On this example, if we approach from either side, we go to positive infinity. And that all comes down to the fact that we've got an even exponent here and an odd exponent here. You can think of this as being this to the first power. So what I want to look at is, how do we find vertical asymptotes? I guess one thing I should say first, though, is we can write this out as the limit as x goes to 3. On this one, if we approach from the left of f of x, this gives us minus infinity. If we approach from the right, toward the asymptote, we go to positive infinity. And so the overall two-sided limit of this f of x, shouldn't say equal, it just doesn't equal anything. It does not exist. This one over here, this limit as x goes to negative 2. For this one, we just say it's infinity. Now, there's a small technicality here. When we say a limit is infinity, we're saying that there is no limit. So it's technically correct to also say that each of these limits where I've got an infinity is technically correct to say that that limit does not exist. But by saying infinity or negative infinity, it's more descriptive of the behavior of the function near that x value. All right, let's look at a couple of examples. Let's find any vertical asymptotes of this function here by looking at its graph. Now, actually, before we do that, there's supposed to be an additional x right here that somehow got left off. Let's look at that on Desmos. So this function, if I graph it, let's see, I've already got it in here. If you look at it, let's see, Desmos is giving me a few artifacts here. You can see here at 0, there's a vertical asymptote. And there's also one over here at 3. Now Desmos is artifacting on me here. It looks like there's a vertical line through there at 3, but there's not. So anyway, this has two vertical asymptotes. And we could find those by doing, we could factor the denominator. Wait, I said factor it, not copy it. If we could factor out an x, and then we're left with x minus 3 squared. And so notice, this right here gives us this asymptote, and x minus 3 squared gives us that asymptote. And again, notice, the asymptote here at 3 is one where both of them go in the same direction. They both go to infinity. And at 0, we've got it going the asymptote is approached as the function approaches the asymptote. From one direction it's going up, and from the other direction it's going down. All right, So if you've got the graph, you can look at it and find the asymptotes. But what if you want to find the asymptotes without doing a graph? Well, let's look at this. On this one, we've got we've got this function. Now, it looks like we're going to have a vertical asymptote at 3, and I should be specific here. Vertical asymptote at x equals 3 and x equals -1. Now, I get those because those are the two numbers that make the denominator 0. Now, you have to be a little bit careful about that. I know I said let's do this without using the graph, but let's look at the graph anyway. If I put this graph in, let's see, x minus 4, x plus 5. Then downstairs I've got x minus 3 and x plus 1. Okay, and if we look at it, you can kind of see the asymptotes. I'm going to just put in the lines x equals 3 and the line x equals -1. I'm going to make both of those asymptotes red and dotted. So those are my two asymptotes there. Well, didn't mean to do that. Now, suppose up here, if instead of x plus 5, if this had been x plus 1, notice that asymptote at -1 goes away. That's because this completely cancels away. Similarly, if I had an x minus 3 up top, the asymptote over at 3 goes away. So the way you get an asymptote, let me put this back. The way you get an asymptote is by having something that makes the denominator 0 that doesn't cancel away. If we were able to cancel two of these away, or cancel, if this had been x minus 3 on top, these would cancel and this would no longer be an asymptote. Let's don't change the problem. Let's look at this limit. Now I guess we're kind of cheating because we're looking at the graph. We're supposed to find the limit as x goes to 3 from the positive side. And from looking at the graph over here, if x approaches 3 from the positive side, we can look and see this is going toward -infinity. So the answer is -infinity. But let's pretend we didn't see that. How could you do this without graphing it? Well, since we're going to -3, we're going to +3 from the positive side, think of it like this. Here's the x value we're approaching, and we're approaching it from over here. So we're going toward 3. So that means that x is greater than 3. But we're asking what happens when it gets really close to 3. So think of x as being a tiny amount larger than 3. If you think about what that means, it means x minus 3 is, if x is a tiny bit bigger than 3, this is going to be a tiny positive number. Now, the way I like to represent that is by saying it's +0. That's kind of bad notation. It's definitely not formal, but it gets the point across. Because what we can do now is we can treat all the x's in here like they're essentially 3. In fact, I'm just going to plug 3 in for this. So my limit, let me copy it down here. I've got x minus 4, x plus 5, x minus 3, and x plus 1. So remember, x is essentially 3, but it's very slightly larger. So that means that these different numbers here, as x goes to 3 from the positive side, x minus 4 is going to become essentially negative 1. X plus 5 is going to be essentially 8. X plus 1 is going to be essentially 4. And x minus 3 is essentially 0. But as we said before, it's going to be positive. So if you look at this, we know the answer is going to be infinity or negative infinity because it's an asymptote, a vertical asymptote. And then we just have to look at the signs. Minus, plus, plus, plus. So this is going to be negative infinity. If let's just say we were approaching 3 from the negative side. If we were doing that, the only thing that would change here is, these numbers are still the same. The only thing it changes is if it's approaching 3 from the negative side, x minus 3 is going to essentially be 0. But in this case, x is a little bit smaller than 3, so this is going to be negative. And that would give us positive infinity. So that's really all there is to these